Kirti, Kirti, Pikesh, Prajwal Gowda, Prajwal Gowda, Ramesh,
Present, sir.
okay, Ratan, Ratan, Rohan, Rohan, Rutik Chopde,
Yes, sir.
right, Rutvik Gune, Sadashiv, Sagar, Sai Prakash,
Yes, sir.
right, Samir Ahmed,
Yes, sir.
okay, Sania,
Present, sir.
right, Sanjay, Sankalp, Sankalp, Sanket,
Yes, sir.
right, Shiraj, Shiraj, Shivnanda Natikar, Shraddha, Shraddha,
Present, sir.
okay, Shubham,
Present, sir.
Shubham, right, Sumit, Sumit, Suraya Banu,
Present, sir.
right, Tejas, Tejas, Vivek, Yamnappa, Gaonkar Rajat Ramchandra,
Present, sir.
right, Manjunath, Pratmesh, Joslino, Soham, Atiya,
Yes, sir.
right. Anybody else joined? Okay. In the last class, I was discussing about the Darlington emitter follower circuit. Is it visible, friends? Is it visible? Yes, is it visible, friends?
Yes,
Are
sir.
you able to?
Yes, sir.
Okay, okay, thank you, thank you. We are discussing about the Darlington emitter follower. This is a circuit. As I told, it's the same as the normal emitter follower, but here we are having two transistors instead of a single transistor connected in a Darlington fashion. That is emitter connected to the base of second transistor and collector of both the transistors are shorted. Okay. The output at emitter follows the input at the base. This is the Darlington emitter follower circuit. For this Darlington emitter circuit, we had drawn the RE model. We have drawn the RE model. Okay, the AC equivalent circuit. This is the resistance RB, base resistance. Then we have the RI, input resistance. Okay, as it is a Darlington pair, instead of RE, we are having RI. Then this is the emitter resistance RE, the collector current beta D into IB, beta D into IB. It is beta D into IB because it's a Darlington pair. Here we are having beta D into IB. Okay. The input current is II, input voltage Vi, input impedance Zi. The impedance between base terminal to ground is Zb. The output current is I naught. I naught, it is nothing but IE current because there is no resistance here. I naught equal to IE. The output voltage is V naught. The current into the base terminal is IB. Right. These are few of the parameters of the, that is Darlington components of the Darlington emitter follower circuit. After we have seen the AC equivalent circuit, let us now derive the various performance parameters of the Darlington emitter follower circuit. First one is the AC input impedance Zi. AC input impedance Zi. Let us apply KVL to the input path of the circuit, input portion of the circuit. If we apply KVL to the input portion of the circuit, It is Vi, the input voltage Vi, this is in parallel. In parallel, Vi is equal to Ib into Ri, Ib into Ri plus I into Re. Vi is equal to Ib into Ri plus I into Re. It is in parallel, right? The voltage across here is in parallel. Therefore, Vi is equal to Ib into Ri plus I into Re according to the KVL. That is Vi is equal to Ib into Ri plus I into Re. Now, how to get the equation for the input impedance? After writing the KVL equation, what we are supposed to do? We have to express the emitter current in terms of the base current. We have to express the emitter current in terms of base current. The equation is I is equal to 1 plus beta into Ib. Equation is I is equal to 1 plus beta into Ib. Here beta is beta d because it's a Darlington pair. Right? Therefore, I will be equal to 1 plus beta d into Ib. I is equal to 1 plus beta d into Ib. Substitute this I equation in the above equation for Vi. We get Vi equal to Ib Ri plus I is 1 plus beta d into Ib into Re. Vi will be equal to Ib Ri plus 1 plus beta d into Ib into Re. Now, if we want to find the value of Zb, first let us find Zb, then let us find the Zi. Now, here Ib is common in this equation. Vi is equal to Ib Ri plus 1 plus beta d into Ib Re. The base current Ib is common. Take Ib common here. Therefore, this will be Vi is equal to Ib into Ri plus 1 plus beta d into Re. Correct? Vi will be equal to take Ib common. So, Ib will be multiplied by Ri plus 1 plus beta d into Re. Now, Vi by Ib, if we take Vi, that divided by Ib. Okay, so how it will be? Vi is equal to Vi is equal to we have Vi is equal to Ib is common, current Ib is common, Ib into Rb, right? What is there inside? Vi is equal to Ib into Ri plus 1 plus beta d into Re. Ri plus 1 plus beta d, 1 plus beta d, beta beta d into Re into Re. Just see, Vi is equal to Ib into Ri plus 1 plus beta d into Re. That means now we will write the equation for Vi by Ib. Vi by Ib. What is Vi by Ib? Let us look into the circuit. Vi by Ib. Vi by Ib is Zb. Input voltage divided by base current. That gives the base impedance. Impedance between base terminal to ground. Vi is the across voltage, parallel voltage, that divided by the base current. That will give the value of Zb. That is between base terminal to ground. Therefore, here we have Vi by Ib. Vi this divided by Ib Vi by Ib is equal to Ri plus 1 plus 1 plus beta d 1 plus beta d one plus beta d into Re. This is nothing but Zb. This is nothing but Zb. Okay. It is impedance between base terminal to ground. It is Ri plus 1 plus beta d into Re. That is what it is written here. ZB is equal to Vi by Ib, that is Ri plus 1 plus beta d into R. Take it as equation 1. Here beta d is very high. Beta d is Darlington current gain, as it is Darlington current gain, which is the current gain of two transistors, right? Therefore beta d is very high. As beta d is very high, therefore this ZB will be equal to 1 plus beta d into Re, 1 plus beta d into Re, or it is Ri, this 1 plus beta d into Re will become simply beta d Re, because beta d is very high. 1 plus beta d into Re is simply beta d Re, then Ri plus beta d Re. Ri plus beta d Re will only be beta d Re, will become only beta d Re. Beta d is very high. 1 plus beta d into Re will become beta d Re. Next equation will be Ri plus beta d Re. So as beta d is very larger, beta d Re is very larger than Ri, therefore ZB will be simply equal to beta d into Re. Take it as equation second. Right? ZB will be simply beta d into Re because beta d is very high. The input impedance Zi, it is given by input voltage divided by input current. Input voltage is Vi divided by input current is Ii. Input voltage by input current, that gives the input impedance. Okay. Now what is input impedance then? Input impedance is this Rb resistance parallel with Zb. Correct? Rb parallel with Zb, that gives the input impedance as seen from the input terminals of the input voltage. If we look from there, then the input impedance is given by Rb parallel with Zb. Correct? Zi is equal to Vi upon Ii, that is Rb parallel with Zb. Take it as equation 3. We got the equation for Zi, that is Rb parallel Zb, where Zb is beta d into Re. Zb is beta d into Re. Therefore, the equation for input impedance is Zi is equal to Rb parallel Zb. Next let us find current gain, EC current gain. If we look into the RE model here, AC equivalent circuit. Okay. Now IE is the output current, or I naught is the output current. I naught divided by II is the current gain. Current gain is nothing but the ratio of output current to input current. I naught is the output current and IA is the input current. Therefore, current gain will be I naught divided by II. It is current gain is I naught divided by II. Now this can be expressed as I naught is the output current, IB is the input current. Therefore, I naught by IB into IB is the output current, II is the input current into IB by II. See here, I naught is output current, IB is input current. Therefore, it is I naught by IB multiplied by IB is output current, II is input current into IB by II. That is, the total current gain I naught divided by II will be I naught by IB into IB by II. AI is equal to I naught by I, that is I naught by IB into IB upon II. But we know that I naught equal to IE. I naught, this current is nothing but the current IE flowing through the RE resistance, because there is no resistance here. That is, I naught is nothing but IE only. Correct? Because there is no resistance in this path. Right? Then IB plus IC is IE. IB plus IC is IE. IE is IB plus IC. Fine. Therefore, I naught is equal to IE. I naught is equal to IE. Substitute I naught equal to I in above equation. Therefore, AI will be equal to I naught is IE by IB into IB by II. IE by IB into IB upon II. Then what is IE? IE is 1 plus beta into IB. Yes or no? IE is 1 plus beta into IB, or 1 plus beta D into IB in this particular emitter follower circuit. As beta D is very larger, or beta D IB is very larger, therefore this will be simply equal to beta D into IB approximately. IE is 1 plus beta D into IB, because 1 plus beta D is approximately equal to beta D, because beta D is very high as compared to 1. Therefore, I will be simply equal to beta D into IB. Beta D into IB. Now here we got the equation for AI. AI main equation is IE by IB into IB by II. We have to find IE by IB, then find IB by I, then substitute in this equation and get the equation for the current gain. So what is IE by IB, students, here? What is IE by IB? IE by IB is equal to what? Beta D. IE divided by IB will be equal to beta D. We got the equation for IE by IB. Then next let us find for IB upon II. IB upon II. Take this as equation 5. Let us apply KCL to the input circuit. If we apply KCL to the input circuit, here. Yes? Any doubts? Let us apply KCL to the input circuit here, input portion. II, that is input current, will be VI by RB, input voltage upon this resistance plus IB. How I am getting this equation? II, look here, II, this is the main current. This is getting split into the current flowing through RB and the current IB. Yes or no? The main current II is getting split into current flowing through RB and the current IB. What is the current flowing through RB? It is VI upon, yes, II is equal to VI upon RB. The current flowing through RB will be the voltage across RB divided by resistance. VI by RB plus this current IB. That is the main current II. So by applying KCL, we get II is equal to VI by RB plus IB. II is equal to VI by RB plus IB. What is VI? What is VI? VI is the voltage across here in parallel. It is IB into ZB. IB into ZB. The current is IB and the impedance is ZB between base terminal to ground. Therefore, I into R, according to Ohm's law, IB into ZB, that gives the voltage VI in parallel here across. VI is equal to IB into ZB. VI is equal to IB into ZB. We get, substitute this VI is IB ZB in above equation. It is II will be equal to IB ZB divided by RB plus IB. Am I right? II is equal to IB ZB divided by RB plus IB. What is common, students, here in this equation? What is common? IB is common, correct? IB is common. Take IB outside. Therefore, this will be IB multiplied by ZB by RB plus 1. IB multiplied by ZB by RB plus 1. Or that is IB. What is the LCM? RB is the LCM. 1 into RB is RB. That is IB into ZB plus RB by RB. LCM is RB. Therefore, this will be IB multiplied by ZB plus RB by RB. Or IB upon II. IB upon II. This is II is equal to IB into ZB plus RB by RB. Therefore, what will be IB by II? IB is the RHS, II is in the LHS. IB by II, if it comes to the denominator, then this RB will come to the numerator on the LHS and ZB plus RB will come to the denominator in the LHS. Correct? That is IB by II will be equal to RB by ZB plus RB. IB upon II will be equal to RB divided by ZB plus RB. Now what we are finding here, students, we are interested in this IB upon II because our main equation is AI current gain equation, that is IE upon IB into IB upon I. We are finding this term IB by II. Okay, equation for this. Therefore, IB by 1 II is equal to RB by ZB plus RB. Take it as equation 6. Use equations 5 and 6 in equation 4. We get equation 5 is IE by IB, that is beta D. Then equation 6 is IB by II. Equation 6 is IB by II, that is RB by ZB plus RB. Now put these two equations in equation 4. Equation 4 is the main equation. AI is IE by IB into IB by II. After substituting, what we get? IE by IB is beta. IE by IB is beta D into IB by II. That is RB by ZB plus RB. That is, write it here. equations 5 and 6, in equation 4, we get A is equal to beta D into RB by ZB plus RB. A is equal to beta D into RB by ZB plus RB. Take it as equation 7. Now substitute for ZB from equation 2. We still can simplify this. We can substitute the equation for ZB. ZB equation from equation 2, what we had written for the AC input impedance. Go back and check what is ZB. ZB is beta D into RE. ZB, what we got for the AC input impedance, ZB is beta D into RE. Substitute this equation here. ZB is approximately beta D into RE. So ZB is beta D into RE. Therefore, AI will be beta D RB by RB plus beta D into RE. AI will be equal to beta D into RB, that divided by RB plus beta D into RE. Take it as equation 8. AI will be equal to beta D into RB, that divided by RB plus beta D into RE. Okay. This is the equation for the current gain. This is the equation for the current gain. Fine. Next, let us find the equation for the voltage gain. We have to refer to the same circuit for the voltage gain. Referring to the above figure, that is referring to the figure of the AC equivalent circuit. What is V0? How much is V0, students? What is V0 equation? Can anybody tell me? Equation for V0 is, look here, V0 is across. V0 is across the output terminals. Therefore, V0 will be equal to, according to Ohm's law, what will be the equation for V0? Yes. What will be the equation for V0? Yes, anybody? Equation for V0. Yes. V0 is equal to IE into RE. V0 is equal to IE into RE. Correct? IE into RE. That is output current multiplied by output resistance. That is output voltage V0. V0 is equal to IE into RE. Write it. V0 is equal to IE into RE. What is IE? IE is 1 plus beta into IB. IE is 1 plus beta into IB. Substitute here 1 plus beta D into IB into RE. Therefore, V0 is equal to IE or that is further equal to 1 plus beta D into IB into RE, because IE is 1 plus beta D into IB. Now let us use equation 1. What is equation 1? We had written for the AC input impedance. This is our equation 1. Vi upon IB is equal to Ri plus 1 plus beta D into RE, or Vi is equal to IB multiplied by Ri plus 1 plus beta D into RE. Correct? Vi will be equal to IB multiplied by Ri plus 1 plus beta D into RE. I am writing the equation for Vi. That is, Vi is equal to IB into Ri plus 1 plus beta D into RE. What is voltage gain equation, students? What is voltage gain? Can anybody tell me? What is voltage gain? How do you define voltage gain? Yes. How do you define voltage gain? Harshgowda? Harshgowda? What is voltage gain? Ramesh? 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 Rutik Chopde?
Sir, it's output voltage to input voltage, sir.
Correct. It's a ratio of output voltage to input voltage. That is V0 by Vi. Good. Therefore, AV is equal to V0 upon Vi. Mute your cell phone. Mute your cell phone. Mute your cell phone. Mute your cell phone. Somebody's cell phone is on muted cell phone. Mute your cell phone. AV is equal to V naught by VI. That is, substitute here. We got the equation for V naught. We got the equation for V naught. That is IE into RE. Then VI is IB into RI plus 1 plus beta D into RE. Substitute these two equations. One for V naught, another one for the VI. V naught is I1 plus beta D into IBRE, or IB into 1 plus beta D into RE. IB into 1 plus beta D into RE, that divided by VI. VI is IB into RI plus 1 plus beta D into RE. What will cancel here? IB and IB will cancel. If IB and IB cancels, what remains? Therefore, voltage gain will be 1 plus beta D into RE, that divided by RI plus 1 plus beta D into RE. AB is equal to 1 plus beta D into RE, that divided by RI plus 1 plus beta D into RE. Okay. But here 1 plus beta D into RE is very larger than RI. 1 plus beta D into RE comparatively is very larger than RI. Therefore, AV will be equal to voltage gain 1 plus beta D into RE, that divided by 1 plus beta D into RE, because 1 plus beta D into RE is comparatively very larger than RI. Therefore, AB will be 1 plus beta D into RE, that divided by 1 plus beta D into RE. Therefore, 1 plus beta D into RE, 1 plus beta D into RE, they will cancel out each other, and AV will be equal to 1. That is, gain is equal to 1. Therefore, for the Darlington emitter follower circuit also, the gain is equal to 1. Gain is 1. If gain is 1, what it indicates, students? What is the meaning of gain equal to 1? Yes, what is the meaning of gain equal to 1? Gain is positive here, right? Gain is positive. What is the polarity of the gain? It is positive, plus 1. That means the output voltage and input voltage are in phase with each other. This indicates that the output voltage and input voltage are in phase with each other. Okay, that is one thing. Another thing is that the gain is unity. The voltage gain is 1. Next, let us find out AC output impedance Z0. Any doubts up till here, students? Any doubts up till now? Yes, any doubts up till now? Sai Prakash? Sai Prakash?
Yes, sir.
Any doubts up till now?
No, sir. No doubt.
Okay. Samir Ahmed? Samir Ahmed?
Yes.
Any doubts, Samir Ahmed?
No, sir.
Okay. Sania?
Yes, sir.
Any questions, Sania?
No, sir.
Any problem in understanding up till now?
No, sir.
Okay, fine. Let us find the output impedance now, the last parameter, performance parameter of the Darlington emitter follower. Now, if we want to determine the output impedance, what we are supposed to do here in the AC equivalent circuit? In the AC equivalent circuit, we have to make Vi equal to 0. We have to turn off the active sources. If you want to find the impedance at the output side, we have to turn off, we have to switch off the active sources. That is, we have to make Vi equal to 0. Vi equal to 0 means it is nothing but short circuit. Okay, we have to short circuit Vi, and then we have to connect an voltage source at the output terminals here, which is equal to the value of output voltage. Right? If you are connecting a voltage source which is equal to the value of output voltage, then it doesn't harm the circuit. Therefore, whatever is the output voltage that we are getting and whatever is the current flowing into the output terminals, into the here we are, the current is moving into the circuit, right? According to the convention of the two-port network, II input current and I naught output current, they move into the circuit. So we are connecting an voltage source at the output side which is having the value equal to the output voltage. That is, when we are making Vi equal to 0, and then we are connecting a voltage source which is equal to the value of the output voltage at the output terminals or across the output terminals. Okay, Let us redraw the circuit now, considering these points. To determine AC output impedance, we apply the following steps. The first step is make Vi equal to 0, that is replace it by short circuit. Then a voltage source V is connected across the output terminals. So if we make these changes, then the resulting circuit will be as follows. This is how the circuit looks like, the AC equivalent circuit. Let us redraw the AC equivalent circuit. See here, in this AC equivalent circuit, we are making Vi 0. Vi is 0, that is, it is a short circuit. Vi is 0, we have Vi equal to 0, then we have RB, right? This is RB, this is between base to, this is ground. Then here we are having Ri, okay? Here we are having Ri, I have drawn it here. This is RB, then here we are having Ri. The base current is moving into the terminal here. This is our emitter terminal. After Ri, we have the emitter terminal. This is Ri, IB, Ri. Fine. Then here we have the emitter terminal, emitter base collector, emitter base collector. So at the emitter terminal, what we are having, students? We are having the emitter resistance Re. We are having the emitter resistance Re. Right? Draw it between emitter terminal to ground. Okay. Then emitter terminal to ground, we are having the Re resistance. Draw it. That is Re, emitter terminal to ground. Then one more, what we are having is the collector current, which is flowing into the emitter terminal. The collector current here is beta D into IB, which is flowing into the emitter terminal. This is emitter, this is base, this is collector. So the currents IB and IC, they are moving into the emitter terminal. Therefore, the current is beta DIB, which is moving into the emitter terminal, which is connected between emitter. This is emitter here. Okay, this is moving into the emitter terminal. And the other side we have the collector. Okay, that is, it is drawn here. This is the current beta DIB, which is moving into the emitter terminal. Then the other side is collector, which is grounded. Fine. Then we are connecting a voltage source equal to the output voltage V. The current flowing is, let us assume it as I. Then the current which is getting split here into Re, let us take it as I dash. I have connected a voltage source equal to the value of the output voltage V, it is V. The current which is moving from the voltage source V is I. The current which is flowing into the resistance Re is I dash. I am assuming it as I dash. Okay. This is the circuit which is redrawn for finding the value of AC output impedance, AC output impedance. Okay. We are finding output impedance, right? What is output impedance? Output impedance is output voltage by output current, that is V divided by I. V is the output voltage, I is the output current. Therefore, V by I gives the output impedance Z0. I is the current driven by the voltage source into output terminals. Now again the circuit will get modified. Again the circuit will get modified like this, because here we have Vi equal to 0. It's a short circuit. Short circuit means, what is the resistance of the short circuit? What is the resistance of the short circuit? Is it 0 or infinity? Resistance of short circuit. Yes, please. What is the resistance of short circuit? Sanket. Sanket. How much is the resistance of short circuit? Whether it is 0 or infinity? Shraddha? Shraddha? Shubham? Shubham? Is anybody? Suraya Banu? Suraya Banu? Rajat? Atiya? Atiya?
Yes, sir.
What is the resistance of short circuit, whether it is 0 or infinity? Short circuit means how much is the resistance, whether it is 0 or infinity?
0.
0, exactly. Short circuit means resistance is 0. Open circuit means resistance is infinite. Therefore, resistance is 0 here. 0 resistance comes in parallel with RB. 0 resistance comes in parallel with RB. 0 into RB divided by 0 plus RB. Parallel combination of 0 and RB. That is 0 into RB divided by 0 plus RB. So it is 0 divided by RB. 0 by RB is 0 only. Therefore, this part will be this portion here. It comes the short circuit. Okay. That means this RB will be connected between base to ground. Between base to ground. Okay. That is drawn here. It is sorry, this RB is 0 here, this equivalent resistance. RI will come between emitter to base. This is a short circuit here. This is a short circuit because it's a parallel combination of 0 and RB. 0 into RB divided by 0 plus RB is 0 divided by RB, that is 0. Therefore, B will be coming down here. It's a short circuit here. It's a short circuit. Okay. Therefore, emitter to base is RI. Then emitter is connected to here. Emitter is to base, in between comes RI. Then on the other side we are having base and one side we are having emitter. Just look at this circuit. This is emitter on one side and here we are having the base. RI will be in between emitter to base. Then what about beta DIB? Beta DIB is here, right? This is coming in between emitter to collector and collector is grounded. Beta DIB is coming in between emitter to collector, right? And collector is grounded. It is drawn here. In between emitter to collector, beta DIB will come and collector is grounded. Fine. Then, so on one side here we are having base, another side is collector. They are shorted. Shorted means as collector is connected to ground, base is also connected to ground. Then what about RE resistance? It is connected between emitter and collector. RE resistance is connected between emitter to collector or emitter to ground. RE is connected between emitter terminal to ground in parallel. Emitter to ground or emitter to collector. Then what about the voltage source? Voltage source is connected between emitter to collector or between emitter to ground. V, this voltage source V. Fine. That is, it is connected between emitter to collector or emitter to ground. Now here let us apply the Kirchhoff's current law to the emitter terminal. Let us apply Kirchhoff's current law to this emitter terminal. According to Kirchhoff's current law, what it tells, what is the statement of the Kirchhoff's current law? The sum of all incoming currents is equal to the sum of all outgoing currents, or the net sum of the currents at the node is always equal to 0. The net sum of the currents at the node is always equal to 0. That is IB, here IB is moving inside, plus beta D IB minus I dash, it's a node here, it's a junction, IB plus beta D IB minus I dash, because it is moving away, then plus I is equal to 0. What are the currents? Plus IB plus beta D IB minus I dash plus I is equal to 0. That is, it is written here, IB plus beta D IB minus I dash plus I is equal to 0. What is IB? IB is equal to, here IB is equal to, this is V, this is RI. So it is minus V by RI. Because if we take the terminals here, current entering is positive here, current leaving is negative here. Current entering at the bottom side towards the base is positive and negative towards the emitter side. Therefore, it is positive negative. Here it is top side positive, below side negative. Correct? So here towards the base it comes positive, towards the emitter side it comes negative. So it is minus plus, here it is plus minus, plus minus. Therefore, we take IB is equal to minus V by RI. IB is equal to minus V by RI. And I dash, what about I dash? I dash voltage across is V. Here it is current entering positive, current leaving negative, positive, negative. Therefore, it is the same polarity as that of voltage, positive, negative, positive, negative. Therefore, I dash will be equal to V by RE. I dash will be equal to V by RE. I dash is equal to V by RE. Let us use these relations in equation 2. In this equation, what we get? Minus V by RI, IB is minus V by RI, plus beta D, IB is minus V by RI, minus I dash is V by RE, plus I is equal to 0. Plus I is equal to 0. Take minus V common. If we take minus V common, that will be 1 upon RI plus beta D by RI plus 1 upon RE is plus I is equal to 0. Right? If you are taking minus V common, this will be multiplied by 1 by RI plus beta D by RI plus 1 upon RE plus I is equal to 0. So if we take this minus term, whatever is there on the other side, it will be plus. Therefore, we get 1 upon Ri plus 1 by Re plus beta d by Ri into V is equal to I. Okay. Now, what we want here, we want the equation in the form of V by I. That is our output impedance. Therefore, V by I is equal to this term will come to the RHS and it will come to the denominator. V by I is equal to Z naught, that is 1 divided by 1 upon Ri plus 1 by Re plus beta d by Ri. Therefore, the equation for output impedance is V by I, that is 1 divided by 1 upon Ri plus 1 by Re plus beta d by Ri. That is this term. Therefore, V by I is equal to 1 divided by 1 upon Ri plus 1 by Re plus beta d by R. This is the equation for the output impedance of the Darlington emitter follower circuit. Next, important characteristics of Darlington emitter follower. What are the features of the Darlington emitter follower circuit? It has very high current gain. It has very high input impedance. It has very low output impedance. Unity voltage gain equal to 1. Just now we saw that voltage gain V naught by Vi equal to 1. And the input and output voltages are in phase with each other. Input and output voltages are in phase with each other. These are the features of the Darlington emitter follower. Very high current gain, very high input impedance, very low output impedance, approximately unity voltage gain, and input and output voltages are in phase with each other. So these are the features of the Darlington emitter follower circuit. Was it understood, students? Any questions here? Today's topics, what all we discussed in today's topics? We started with the Darlington emitter follower, its AC equivalent circuit, and this is its AC equivalent circuit. I told in the last class, the AC equivalent circuit is almost same as that of the AC equivalent circuit of normal emitter follower, but in the normal emitter follower, here we have Re, but here we are having Ri because it is Darlington pair 2 transistors. And here we are having for normal emitter follower beta IB. For Darlington emitter follower, we are having beta D IB. That is the only change. Rest of the things are same. Then we derived the various performance parameters. First one is AC input impedance Zi. To find Zi, we first derived ZB. Then we wrote the equation for Zi as RB parallel ZB. What is ZB? ZB is beta D into Re. Then AC current gain, it is I naught by I is equal to I naught by IB into IB by II. We found out I naught by IB, that is IE by IB. It is beta D. Then IB by II. IB by I is RB divided by ZB plus RB. Therefore, substituting this, what we get here, AI is equal to beta D into RB divided by ZB plus RB. Or AI is substituting for ZB, beta D RB divided by RB plus beta D RE. This is the main equation for the current gain. Then similarly, we found out the voltage gain starting from V naught is equal to IE RE. We found out equation for output voltage, input voltage. Then we substitute in the gain equation, that is V naught by Vi. Then finally we found that voltage gain is 1. It is unity. Output and input voltages are in phase with each other, and the voltage gain is unity. Then later we found out AC output impedance. To find output impedance, we are making Vi 0. That is, it is short circuit. Then we are connecting a voltage source across the output terminals, which is equal to the value of the output voltage. The circuit will be modified like this. Vi equal to 0, it is short circuit, and here we are connecting the voltage source, which is equal to the output voltage. Then 0 and RB parallel combination, 0 resistance and RB resistance parallel combination will be 0. It's a short circuit here. That means in between emitter to base we are having Ri, then base is connected to ground. It's a short circuit. Okay, it is connected to ground. Okay, then in between emitter to collector it is beta DIB. Then in between emitter to collector it is Re. Then in between emitter to collector it is voltage source. Again the circuit will get modified like this. This is how the circuit looks like. We are applying KCL to the emitter node. Once we apply KCL, then we get the main equation IB plus beta DIB minus I dash plus I is equal to 0. We are substituting for IB and I dash into the main equation, and we are getting the value of output impedance as 1 divided by 1 upon Ri plus 1 upon Re plus beta D by Ri. Then the features of Darlington emitter follower are the characteristics: very high current gain, very high input impedance, very low output impedance, approximately unity voltage gain, and unit input and output voltages are in phase with each other. Any questions here, students? Shraddha, Shraddha, Shraddha. Any questions? Shubham, Shubham.
No, sir.
Okay. Suraya Banu, Suraya Banu. Rajat, Gaonkar Rajat Ramchandra. Any questions? Atiya, Atiya.
Yes, sir.
Any questions, Atiya?
No, sir.
Okay, fine. Sanket, Sanket.
Yes, sir.
Any questions, Sanket?
No, sir.
Okay. Sania, any doubts? Sania, Samir
No, sir.
Ahmad.
No doubt.
Fine. Samir Ahmad, Samir
Yes.
Ahmad. Any problem in understanding Samir Ahmad?
No, sir.
Any problem, Samir Ahmad?
No, sir.
Okay. Sai Prakash, Sai
Yes,
Prakash.
sir. Yes, sir.
Was the topics clear, Sai Prakash? Today's topics.
Yes, sir.
Okay. Rutik Chopde, Rutik.
Yes, sir.
Any problem in understanding Rutik?
No, sir.
Okay, fine.
Understood, sir.
Good. Ramesh, Ramesh. Janvi, Janvi. Okay. So we'll continue in the next class, students, with the next subsequent topics in the module that we'll take up in the next class. Thank you.